Good day everyone. Today I will going to demonstrate to you on how to use any of the test statistics. I am going to explain the systematic method of determining whether the data is normally distributed or not using the method of Kurtosis. But first, we are going to define what statistical hypothesis is. A statistical hypothesis is an assertion or conjecture concerning one or more population. So, why do we need to test the normality of the data? In order to distinguish whether the data are normally distributed or it passed or failed the normality assumption. What is Kurtosis? Kurtosis is a measure of the sample or population that identifies how flat or big it is with respect to a normal distribution. So, here is now the step-by-step process of Kurtosis. First, we need to plot the data on the table using Excel or by hand. But I prefer to use Excel because once we input the data, it has an automatic result. So here's our data. For X, we have 15, 14, 15, 8, 13, 10, 11, 19, 17, 10, 11, 13, 13, 14, 14, 9, 16, 12, 11. Now let's proceed to the next column, which is X minus the mean. In order to find the mean, we are going to add all the data and divided it on the number of the data. So here's the formula in finding the mean, where mean is equal to the summation of X or the summation of all data over the n, where n is equal to the total number of the data. Substitute the value. We already have the result for the summation of all the data, which is 245 divided by 19, which is the total number of data. So when we divide 245 by 19, the result is 12.89. So we have now the value of mean, which is 12.89. Since we already found the value of the mean, which is 12.89, we can now find the value for X minus mean. Using Excel, we just need to input a formula, which is equals A2 minus 12.89. Then drag it onto the last row to automatically find the value. And that's the value. In order to find the summation of X minus the mean, we are going to use the formula equals sum the quantity of the capital letter B 2 up to B20, then press enter. Next, we are going to find the value of the quantity of X minus the mean squared. We will use the formula equals B2 squared then press enter and drag it onto the last row to find all the result for the quantity of x minus mean squared. To find the summation of the quantity of x minus the mean squared, we are going to use the formula equals sum C2 up to C20 and then enter. Next, same process of what we did, but for the quantity of x minus the mean raised to 4, we are going to use the formula b equals b2 raised to 4, then drag. And to find the summation of the quantity of x minus mean raised to 4, we are going to use the formula equals sum D2 up to D20, then press enter again. For the last, we are going to find the quantity of x minus mean raised to the 4th power over s raised to the 4th power. But before that, we are going to find first the standard deviation. And the formula for finding the standard deviation is standard deviation is equal to the square root of the summation of the quantity of x minus the mean squared over the total number minus 1. Now let's substitute the value of x minus mean squared. And the result is 2.83. That's now the value of our standard deviation. Since we already have the value for standard deviation, same process of what we did to column 1, 2, 3, and 4. But for now, we're going to use the formula D2 equals D2 over 2.83 raised to 4th power, then enter, then drag it into the last row, then we have the value. Then to find the standard deviation of the quantity of x minus the mean raised to the 4th power over s to the raised to 4th power, we're going to use the formula equals sum E2 up to E20, then enter. And that's the value now. And here's our complete data. We have the value of the quantity of x minus mean, the quantity of x minus mean squared raised to 4th power, then the quantity of x minus mean to the raised to the fourth power over s raised to the fourth power. Now, let's find the kurtosis of the theta, where kurtosis is equal to the n times the quantity of n plus 1 over the quantity of n minus 1 times the quantity of n minus 2 times the quantity of n minus 3 times the summation of x minus the mean all over the standard deviation over raised to the fourth power minus 3 times the quantity of n minus 1 squared over the quantity of n minus 2 times the quantity of n minus 3. And just substitute the value where n is equal to 19 and the summation of x minus the mean all over the standard deviation raised to the fourth power is 43.58993553 and solved. And we will get the negative 0.1909 by solving the data following the formula. Since we already have the kurtosis of the data, now let's proceed to the standard error of the kurtosis, where standard error of the kurtosis is equal to the square root of 24 times the quantity of n minus 1 squared all over the quantity of n minus 2 times the quantity of n minus 3 times the quantity of n plus 5 times the quantity of n plus 3, and then just substitute the value and then solve, and then the result is 1.0143. And last, we are going to use the kurtosis and standard error of the kurtosis to find a z-score, where z-score is equal to the kurtosis all over minus 0 all over the standard error of the kurtosis, and just substitute the value of what we solved earlier, negative 0.1909 minus 0 all over 1.0143, and the result is negative 0.1882. Since the z-score value does not fall within the range of negative 1.96 and positive 1.96, the sample has failed the normality assumption of kurtosis. That is the systematic process of finding a z-score using the kurtosis and the standard error of the kurtosis of the data.